So the problem we're given today is pretty straightforward. We've got a quadrilateral. Three of the sides, CD, BC, and AB, are given to us. They're 2019, 2018, and 2017 respectively. And the information that we're given is that the two diagonals in the quadrilateral are perpendicular. So this is something that's referred to as an orthodiagonal quadrilateral. So the problem is asking us to find what AD is. Side that doesn't have a length given, and we're supposed to find what that is given that three sides are 2019, 2018, 2017, and the two diagonals are perpendicular. So the way I solved this problem was by assigning each of the diagonals a variable and then using that to set up systems of equations with the Pythagorean theorem. So I called this one, you can call these things anything, but I'm just calling them X, Y, A, and B. And so now we just apply the Pythagorean theorem. I'm going to call this center O just for easier reference, and I'll be referencing that throughout the problem. So we can see triangle COB is a right triangle as given to us in the problem. We know that all four of those center angles that involve O are all right. They're all 90 degrees. So we can set up a Pythagorean theorem with triangle COB. We know A squared plus Y squared is equal to 2018 squared. Then we can do the same thing with the other triangles. We see triangle COD, which is X squared plus Y squared equals 2019 squared, which is the hypotenuse of that triangle. And one more triangle that we're given is triangle AOB, and we can see that the Pythagorean theorem there is A squared plus B squared equals 2017 squared. And let's not forget what the problem is asking. We want to find what AD is, and so we can do that by setting up one more Pythagorean theorem but leaving it in terms of a variable. We know that X squared, and by the way, we're looking at triangle AOD. We know that X squared plus B squared is equal to AD squared, which is that length that we don't know. So basically, we just want to find what X squared plus B squared is, and then we can take the square root of that to find what AD is. So we want to get the X squared and the B squared terms together, because that will be something that's in our final equation. So let's add these two equations together, the 2019 squared and 2017 squared. So when we add those together, we get X squared plus Y squared plus A squared plus B squared is equal to 2019 squared plus 2017 squared. So now we have X squared and B squared, but we still have an A squared and Y squared in this equation in the bottom. So the best way to get rid of that is to get an A squared plus Y squared from that first equation and subtract that out. So we bring that to the bottom, we get minus A squared plus Y squared. I'm just going to rewrite that here as Y squared plus A squared, same thing, is equal to then the negative of 2018 squared. And then when we subtract these two equations, we get X squared, then the Y squareds cancel, the A squareds cancel, and the B squared is still there. So X squared plus B squared is equal to 2019 squared plus 2017 squared, 17 squared minus 2018 squared. So things were getting kind of messy, so I just rewrote that here. We have X squared plus B squared is equal to AD squared is equal to 2019 squared plus 2017 squared minus 2018 squared. So we could just take the square root of this, solve for AD, but that's not clean, and we don't always have access to a calculator in a test or something, so I'm going to try to make this as clean as possible. So we can start out by using difference of squares with the 2019 squared minus 2018 squared. So let's rewrite this. We have 2019 squared minus 2018 squared plus 2017 squared. This is equal to 2019 plus 2018 times 2019 minus 2018 plus 2017 squared by difference of squares, right? So this becomes 4037, and this becomes just 1. So it's 2017 squared plus 4037. So it's pretty clean already, but I think we can go even further. We can do 2018 minus 1 squared plus 2018 times 2 plus 1 as a rewrite of this equation. 2018 minus 1 squared plus 2018 times 2018 times 2 plus 1. So what happens when we expand this square out? We get 2018 squared minus 2 times 2018 plus 1 plus 2018 times 2 plus 1. Now this is where it becomes even cleaner. The minus 2 times 2018 and the plus 2 times 2018 cancel out. And you're left with, I don't know why I have this thing here. That's not supposed to be there. Oh, that was a parenthesis. Whatever. So we're left with 2018 squared plus 1 plus 1. It's 2018 squared plus 2. But the important thing to remember is that this is AD squared. Remember from up here. That's x squared plus b squared is equal to AD squared because we use the Pythagorean theorem. So we have to take the square root of this. And that is our final answer. This turns out to be basically 2018. It's like 2018.0000004 or something like that, if I remember correctly. But nevertheless, this is a clean way to do it, and that's probably the form you're going to leave it in when you're answering this on a competition or in a test or something.